Okay, howdy. So we're going to move on in our discussion for today's lesson, and we're going to begin talking about declarations. So names are a lot easier to remember than addresses. This is kind of true in our everyday life. It's a lot easier to say we're going to the grocery store, to so-and-so's house, opposed to having to recall the explicit address of each of those locations. Likewise, in our program, it's more convenient to use names. It's something we're familiar with and use on a daily basis, opposed to having to remember long addresses as to where those variables actually live. And this is at this point getting into a brief review, each named object is going to have a specific type associated with it. That's going to determine, again, the values that we can put inside the object, as well as the set of operations that can be applied to objects of that type. Before a name can be used, we always have to inform the compiler of its type through a declaration. So you can't just write in your program somewhere I is equal to 10. What is I? Is it an integer? Is it a character? Is it a string, which we'll get into later? The compiler would not be able to check to see whether or not 10 is a valid value to put into I. It would also not be able to check are the operations that you're attempting to apply to it valid operations for objects of that type. So to ensure that we're using the type appropriately, we must say that I is an integer object. That's just a bare bones declaration where we've introduced the name I. The compiler now knows that I is an int and it should be treated as such. As we also pointed out too, many declarations are also definitions, and this is true for all of the built-in types that we've talked about today, all the built-in primitive types. So let's decompose the actual underlying structure of a declaration. A declaration is going to be composed of 4 different parts. There's an optional specifier, which could be an initial keyword that specifies some non-type attribute of the object being introduced. Const is going to be one of those non-type attributes that we'll expand upon a little bit here. We'll also see later on there's virtual, extern. There's a number of them, but const is going to be the one that's going to be introduced today, in fact. A base type. So in our int I, that is the base type of object being created. A declarator is going to be composed of a name and optionally some declarator operator that can be either prefix or postfix. So in this case, we don't have a declarator operator, but we do have the name. So declarator only name. And then the 4th part is, like the first part, also optional. So notice here that we did not have an optional specifier prefixing the base type. However, and we should always do this for variables of the primitive types, is we should always provide an initializer for them. And so they should always be initialized. So we can say I is going to be an integer object. That's going to start out with the value of, 11 in this case. So right here, optional initializer, but we'll say not optional for primitive types. In other words, I'm strongly encouraging you to always initialize any variable that's of a primitive type. So let's go ahead and look at the declarator a little bit closely. I mean, it's pretty, a name's kind of pretty obvious, but what are these declarator operator? So we talked about a declarator as being composed of a name and optionally some declarator operators. These operators, or at least the most common ones, include the following. We could have a prefix, asterisk, to say that we're creating a compound type, a pointer, that would look something like int, asterisk, p, would say that p is essentially going to be a pointer to an integer. Another declarator operator could be int. Const p, where p is going to be a constant pointer to an integer object. And don't worry, we haven't expanded upon these yet. I'm just reading it out. But as you can see here, I'm always reading from right to left to kind of understand what a particular identifier is. So in this case, p is going to be a constant pointer to an integer object. P is going to be a pointer to an integer object. This is just a little kind of trick that seems to work the majority of the time, more often than not. We could have a reference. Again, just adding in the declarator operator. What we'll see here is references always have to be initialized. I don't want to go into any more detail, but so they'll always have an initializer. You can't create one without one. We'll get into arrays a bit later, but you could say something like int r is going to be an array. Notice here that this declarator operator is postfix. It comes after the name. It does not precede it. And finally, I think we're all kind of familiar with functions to some extent. We've definitely seen the main function, I believe, multiple times now, and a couple of code snippets today, as well as the actual Hello World application from yesterday. So to talk about, I guess, the declaration of a function, in this case, you have the base type, which for main would be something like int. You have a name followed by a declarator operator. In this case, it's going to be a parameter list. We'll leave it empty. And it won't have an initializer for the function, so it would just be terminated if it was a declaration. And we'll get into how a declaration and definition differs when speaking about entities such as functions, classes, etc. But for right now, hopefully that helps you decompose the structure of a declaration a bit more. Declarator operators are going to apply to individual names only. So if you have something like int b, in this case, is simply going to be an integer object. A is going to be the pointer to the integer object, because again, these operators apply to individual names only. And in all honesty, can't remember if this is in the Google style guide or not, but there should only really be one name being introduced per line of declaration. So this should really have been split up into 2 lines just to make it very clear what's happening here, and it leaves no room for an incorrect interpretation. So I mentioned that our declarators have these declarator operators, and then we kind of glossed over, we gave a couple of examples, but we definitely skipped over the first part, that the optional non-type attribute specifier. We're going to go ahead and introduce one of them here. And the one that we'll be introducing is constant expression to essentially declare read-only objects. So we can declare symbolic constants, and these are essentially going to be objects that cannot be assigned to after initialization. To do this, we can use the non-type specifier const in the object's definition. So notice here, we've actually got it listed out. Notice it precedes the base type. We're always going to do it this way. It could also come after the base type, but we're not going to introduce that ambiguity here. We're always going to use the non-type specifiers in this manner. Notice that when we're introducing a constant, the name is actually going to be a bit different than that of local variables. We'll always denote a constant with K, followed by the name of the constant in snake case. So essentially uppercase letters to differentiate out breaks within the identifier. So read only break variable. So we're going to prefer constants with descriptive names in your code over magic numbers. So I've been doing a lot of this, just as examples. You should not be doing this in your code. In this case, 7's a magic number. What the heck is 7? Where did it come from? What's its use? Why 7? Why not 8? So, try to avoid that. If you're restricting something to some specific value, go ahead and create a global constant for that with some information as to why it's being set that way, and then use the constant throughout the execution of your program. But a lot of times we'll be interacting with data. We'll have more kind of information about the values that our variable should take on. Maybe they're returned from computations, etc. So we shouldn't be seeing that many magic numbers dispersed throughout our program, and we definitely need to limit their presence as much as feasibly possible. There are situations where you might have to do something like index is equal to 0. If you're thinking about the declaration of a for loop or for statement to iterate through some sort of collection of objects, or maybe an int from its first location to the end. But again, we haven't introduced those constructs just yet, but we'll get to them. So that's const, and that would probably you'll see it present most likely when we get into constant references, or reference to const is probably a better way to read it. That'll be kind of scattered throughout. But anyhow, when we're talking about those symbolic constants, or the constants that are kind of utilized throughout the execution of our program. So I guess what I'm saying is const a lot of times will receive its value at runtime. It has to be initialized. You can't create a constant variable without providing an initializer, because it's read-only from its point of declaration forward. Now, if you know the value at compile time and you're setting it, it's recommended to use a constant expression to communicate that. So instead of using const, you're using constant expr. How this differs from const is you could write something like, you could get a value at runtime and then assign it to a constant variable. A constant expression, you have to know the actual value that's being assigned to the variable before your program even compiles. And for a lot of global variables, this will be the case. And these are going to be, whether you're creating a constant variable through either constant expression or const, you're always going to go ahead and name it with a leading K followed by a mixed case to denote the constant nature, and that this particular variable as it presents through your code is different. It's a constant. It's not simply a local variable that we're using. So it allows us to differentiate from other variables if we're using a unique naming scheme to denote them. Then next is going to be initialization and assignment, and then today's lesson is complete.